Dear students, under the topic vector differentiation, here we have result 14 and 15. These two results are very significant in the examination point of view. Now here we have to prove that the result 14 is nebula square of r power n is equal to n multiplied with n plus 1 multiplied with r to the power n minus 2. So far we have learnt about nebula. Now here we have nebula square. This is known as the Laplacian operator. So first we shall prove result 14. That is, we have to prove that nebula square of r power n is equal to n multiplied with n plus 1 multiplied with r to the power n minus 2. Now in order to prove this, first we shall consider the left hand side. The left hand side is nebula square of r to the power n. This can be written as nebula dot product with nebula to the nebula of, so this is dot product with r to the power n. So nebula dot product with nebula r power n. So nebula square can be written in this manner. Now first we will calculate what is nebula r to the power n. In order to calculate this, we have to use a vector identity which we have learnt previously. That is, we have learnt that nebula f of r is equal to f dash of r multiplied with r cap. Now here how to use this identity over here? We want to find nebula r to the power n. So nebula r power n, that is f of r is equal to r power n. So that is equal to, so if f of r is equal to r to the power n, then what about f dash of r? It will be equal to n r to the power n minus 1. So we shall substitute that. So n r to the power n minus 1 multiplied with r cap. But we know that r cap is equal to r vector divided by modulus of r, which is r. So let us make use of this over here. So this will be equal to n r to the power n minus 1 multiplied with r cap, that is r vector divided by r. So that is further equal to n. Now this r in the denominator, when taken to the numerator, it will be r to the power minus 1. So the powers of r can be added and we get r to the power n minus 2 into r vector. So therefore we have obtained nebula r power n to be equal to n r to the power n minus 2 multiplied with r vector. Now we shall substitute this over here. So therefore nebula square, that is, this turns out to be nebula square of r to the power n, which is equal to nebula dot product with, what is nebula r power n? We have calculated it as n r to the power n minus 2 r vector. Now here we are going to make use of another formula from vector calculus, that is vector differentiation. What is nebula dot product with phi a vector? So this is equal to, we have already learned this. This is nebula phi multiplied with, dot product with a vector plus phi multiplied with nebula dot a vector. Now we are going to make use of this over here. That is, at the place of phi, we have r to the power n minus 2. This n can be taken out common. It is a constant which can be taken out. So at the place of phi, we are having r to the power n minus 1. And at the place of a vector, we are having r vector. So phi is r to the power n minus 2. And then a vector is r vector. So we can apply this in this formula. So that will be further equal to, that is this one, nebula square of r to the power n will be equal to, n we will take common out and we will have this formula now. So nebula phi, what is phi? R power n minus 2. So nebula r to the power n minus 2 dot product with a vector, which is r vector. So a vector is r vector plus phi is r to the power n minus 2 multiplied with nebula dot r vector. Now further, here we can write this is equal to n multiplied with, now we will evaluate what is nebula r to the power n minus 2. How to evaluate this? Again we have to make use of this formula that we used previously. Now at the place of f of r, we are having r to the power n minus 2. So what is the formula? It is f dash of r multiplied with r cap. So we have to apply here. What is f dash of r here? That is f of r is r to the power n minus 2. So I will write here f of r is what? R to the power n minus 2. So f dash of r will be n minus 2 r to the power n minus 3. So we shall make use of this. So f dash of r, so n minus 2 r to the power n minus 3 multiplied with r cap, then dot product with r vector plus r to the power n minus 2. And what is nebula dot r vector? Nebula dot r vector is 3. We have already learnt as a result in our previous video lecture. Kindly you may go through it. So this, the value of nebula dot r vector is 3, so I have substituted that here. Now we shall simplify this further. So this will be equal to n multiplied with n minus 2 r to the power n minus 3, and r cap can be written as r vector divided by r dot product with r vector plus 3 r to the power n minus 2. But what is r vector dot r vector? It is equal to r square. So we shall make use of this now. So this will be further equal to n multiplied with n minus 2 r to the power n minus 3 r square divided by r plus 3 r to the power n minus 2. Now if you see, one of the r gets cancelled and this can be added up with this. So this will be equal to n multiplied with n minus 2 r to the power n minus 3 plus 1. So it will be n minus 2 plus 3 r to the power n minus 2. Now this r to the power n minus 2 is common to these two terms. So it can be taken out, and so we will be having n minus 2. So here it is n minus 2 plus 3. That r to the power which is n minus 2 which is common, I have taken it here to the right. So that is equal to n multiplied with, actually this is n minus 2. Okay, n minus 2 plus 3. So what is minus 2 plus 3? It is plus 1. So n plus 1 multiplied with r to the power n minus 2. So therefore we have obtained the required result. That is, we wanted to prove that nebula square of r power n is equal to n into n plus 1 r to the power n minus 2. And hence we have proved this result. So we have obtained this result. Now the next result is nebula square of 1 by r is equal to 0. So we shall prove this. Actually we are going to make use of this result and we are going to prove this. So let us see the proof now. So now we are going to prove that nebula square of 1 by r is equal to 0, for which we will be making use of this result. We know that nebula square of r power n is equal to n into n plus 1 multiplied with r to the power n minus 2. Now if you see, this we can write as nebula square of 1 by r can be written as nebula square of r to the power minus 1. So now when we use this formula over here, what is the value of n? Value of n is equal to minus 1. So in this formula, we have to make use of n as minus 1. So what we will get? N. So minus 1 multiplied with n is minus 1. So minus 1 plus 1 r to the power minus 1 minus 2. That is equal to, if you see here, we have minus 1 plus 1 which will turn out to be 0, and because of that this will completely be equal to 0. Therefore we have proved that nebula square of 1 by r is equal to 0. Hence we are done with the proof. So if this is asked in the examination, we have to first prove the previous result followed by this result. So hope you have understood both the results. Kindly follow the next video lecture for another significant result under vector differentiation. Thank you.